Hi, welcome back to this channel. In this video, we will focus on the physical properties of alkane, which is boiling point, solubility, and one of the chemical properties of alkane, which is the combustion. Before we discuss the physical properties of alkane, maybe we have to complete another two objective questions about the naming of alkanes. Okay, so this question is objective question. So from the option here, basically we notice that there are the longest carbon chain consists of 7 carbons. And then next one is we can see from here there is 3 substitutes for option A and B, and then there are only two substitutes for option C and D. So basically when we do the naming of the alkane, so first we need to know that we must have the longest carbon chain. Okay, after we have the longest carbon chain, we try to select the one with more substitute. So then from this second requirement here, we know that options C and D basically will be out because they only have 2 substitutes. Okay, then next one we will looking at the lowest number for substitute. So and then now how we know it is lower? So we total up 3, 6 and 4 will equal to 13, while we total up 2, 5, 4 is 11. So then now basically we can try to check is it the structure can have the name of the option B, 7 7 carbon in the longest carbon chain. 1, 2, 3, 4, 5, 6, 7. So this is the longest carbon chain. Then since we need from here, we already have the idea. The first substitute is at the second carbon. So we know that this is first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon, and seventh carbon. Based on now here we have 2 methyl, 5 also methyl, and then for the fourth here we have 1 carbon, 2 carbon, 3 carbon, so this is propyl. So that's why 2,5-dimethyl 4-propylhexane is the answer. Question 6. Identify hydrocarbon which contain a tertiary carbon. So before we can identify the tertiary carbon, we must know that if we want to classify the carbon, we have to make sure the carbon must be sp3 carbon, which means consists of 4 single bond. But then when we look at the name here, and with ANE, ANE, and ANE, basically we know they are alkane. So if they are alkane, they doesn't have any functional group, means that the bond between carbon-carbon always is single bond. So now let's draw the structure. 2-methyl-propane. So if I have propane means 3 carbon, 2 methyl. So and then I complete with the hydrogen or the bonds. So this one very obvious. This is primary, 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 and the middle one here is tertiary carbon. So 2-methyl-propane consists of tertiary carbon. Then now we look at the second one, cyclopropane. So that means we will have a triangle and then with a methyl group. So this one we will going to CH2, CH2, and then this one is CH. So again, this is primary, this is secondary, this one also secondary, and this is tertiary carbon. So methyl cyclopropane also contain a tertiary carbon. Next one is butane. Butane consists of 4 carbon. So CH3, CH2, CH2, and CH3. primary carbon, secondary carbon, secondary carbon, and primary carbon. So from here we know that butane does not have tertiary carbon. So the answer for this question is 1 and 2, only B. Okay, let's start the physical properties of alkane boiling point. Okay, let's look at the physical state of the alkane. Generally, alkane with 1 to 4 carbon, the physical state will be gaseous at room temperature and 1 atm. While 5 to 17 carbon, basically they are in the liquid form, and more than that, normally they will be in the waxy solid form. So now we look at the boiling point. As we know, the general formula of alkane is CnH2n plus 2. Based on the bond axis will be between the carbon and hydrogen bond. And then this bond is non-polar bond. So basically, alkane will be a non-polar molecule. So non-polar molecule basically always will only have weak van der Waals force, which if it is more specific is London dispersion force only. Dispersion force. So and then as we know, the van der Waals force or the London dispersion force will be depends on the molecular size. The bigger the molecular size means that the bigger or the larger the contact surface area, hence the stronger the van der Waals force and more energy required to overcome this intermolecular force, and boiling point will become higher. So now, this is the boiling point and the melting point of straight chain alkane. So what we want to emphasize here is straight chain alkane. And then at the x-axis, we will notice that the number of carbon is increasing. And then the melting point and the boiling point is getting higher and higher. Okay, so that is a diagram which support the statement that mentioned in the previous slide. So now we need to look at here. Example, boiling point of propane. Propane consists of 3 carbon, butane 4 carbon, while hexane 6 carbon. So among these 3, definitely hexane has the highest boiling point, while the propane with the lowest boiling point due to the molecular size. Even we are looking at the number of carbon, but when you do the explanation, we are going to use the term molecular size as what we learned in semester 1. Okay, so next one, boiling point of pentane. From the name here, pentane have 5 carbon, 3 methyl pentane, pentane 5 carbon, methyl is 1. So the 3 here again, just reminder, is the position of the methyl group. So total here will have 6 carbon. So that's why 3-methylpentane has higher boiling point than pentane due to the molecular size as well. Okay, from the previous slide, we already have the idea if the alkane have larger molecular size, which may have more carbon, the boiling point is higher. How about if the alkane has similar number of carbons with different branches? So based on this statement, they say that if the alkane has same number of carbons, then the second requirement that we look at it will be look at the branch. The more the branch, the lower the boiling point. So now let's look at one set of data here. Cyclopentane 5 carbon, pentane 5 carbon, butane 4 carbon, methyl 1 carbon, total 5 carbon. Propane 3 carbon, methyl 1 carbon, but we have di 2 methyl. So that means 2 times 1 plus 3 also equal to 5 carbon. All these 4 alkanes consist of 5 carbon, but then now we look at the branches, the number of branches. So the last one, 2,2-dimethyl propane, has more branch. So then we look at their boiling point is the lowest. So that's why we come up with this statement. If the number of carbon are similar for certain alkanes, so we will looking at their branch. The more branches, the lower the boiling point. So now let's look at how we are going to describe. Why more branches? The boiling point is lower. Okay, branches make the molecule more compact, and then the contact surface area becomes smaller. So which means the van der Waals force will become weaker and less energy required to overcome the boiling point, and will make to overcome the intermolecular force and make the boiling point decreasing. So then now we look at first one and second, cyclopentane and pentane. Basically, both of them also have 5 carbon, but what's the difference between them is one is cyclic compound and one is linear. So between these two, we look at the data here. 49 degrees Celsius is higher than 36 degrees Celsius. So that means cyclic compound generally will have larger contact surface area compared to the linear compound. So here we come out another idea. Cycloalkane has larger contact surface area compared to straight chain for the same carbon. So this is the another point that you have to remember. So let's do the conclusion now. Okay, the boiling point of alkane. First thing that we check is the number of carbon. The higher or the more the number of carbon, the higher the boiling point. If the number of carbon similar, so we will look at the branch. Okay, or we consider the cyclic has the highest boiling point, followed by linear, and the more branch, the lowest the boiling point. Let's proceed to tutorial question 4a. Arrange the following in order of increasing boiling point and then explain your answer. So basically for the wording of explain your answer, you may refer to the notes. So here I just want to guide you to get the idea what is the factors that we are going to use. Okay, look at 4a. As usual, just recall back, every time when we get the question about the boiling point, first thing to do is determine number of carbon for each compound. Pentane 5 carbon, ethane 2 carbon, butane 4 carbon. So from the name here, we know that they are straight chain alkane with different number of carbon, which means different molecular size. So that means we just look at the factor number of carbon. So the smaller the molecular size, the lower the boiling point. So because of they want us to arrange in the increasing order, so that's why ethane will has the lowest boiling point, followed by butane, and then the highest boiling point is the pentane. So you can explain accordingly using the ethane has lowest boiling point because have lowest molecular size. Smallest molecular size. Therefore, smallest contact surface area. Then weakest van der Waals force and less energy required. So that's why the ethane will have the lowest boiling point. Now proceed to question B. So try to find out how many carbon for each compound first. 1 carbon, 4, 5. So plus this one, 1. So to get all together 6 carbon. 1 carbon plus 3, 4, 5, 6. 6 carbon. 1 carbon, 2, 3, 4, 5, 6 carbon. Okay, so again, if they have same, first we look at the number of carbon. So if same, then second thing we look at is the branches. Okay, if number of carbon different, so we will check here. Number of carbon higher, boiling point higher. Okay, so this is in 4A that we already discussed. Now we are at 4B. If the number of carbon same, then second we go to the branches. More branches, boiling point lower. Okay, then before we continue, maybe we can draw out the structure first. So CH3, CH2, 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 CH2 4 times and then CH3. So means that the first one is the straight chain. While the second one, C, we have 3 CH3 attached to the same carbon. And then CH2, CH3. So this one have branch, 2 branches. Okay, then the last one, CH, CH3, CH3, CH2, CH2, CH3. So this is the hydrogen. So for this one, basically, we consider only have one branch. Okay, so let's highlight the branch. So this is the branch, and then this is the branch. So based on statement here, the more branch, the lower the boiling point. So that means if we want to arrange, so this one has the lowest boiling point, followed by this, and then the last one, highest boiling point is the hexane. So since we already know the naming, so maybe we also can do the naming. This is hexane. This one is 2,2-dimethyl butane. And then this one is 2-methyl pentane. Okay, so then your explanation can be mentioned. More branch means more compact. So lowest contact surface area, weaker van der Waals force, less energy required to overcome the the intermolecular force, so lower boiling point. Okay. Tutorial question 4C. Cyclobutane have 4 carbon. Butane also have 4 carbon. 2-methylpropane, methyl 1 carbon, propane 3 carbon. So total also 4 carbon. So when this happens, then we will see that 2-methylpropane have the branch. So that's why it will have the lowest boiling point. And then followed by butane, which is a straight chain alkane. And the cyclobutane will going to have the highest boiling point. So this one, they have same number of carbon, means that they have similar molecular size. Once this is the similar factor, then next we are going to discuss about the contact surface area. The larger the contact surface area, the higher the boiling point. So from here now, we will know that this cyclobutane has the greatest contact surface area, followed by the butane, which is straight chain, and the 2-methylpropane has the smallest contact surface area. Objective question 4. Identify the alkane with the highest boiling point. Again, look at the number of carbon. N-octane means that have 8 carbon. Methyl 1 carbon plus heptane 7, so also equal to 8 carbon. 2,2-dimethylhexane methyl, we have 2 methyl, and then the parent is hexane 6 carbon, total 8 carbon. 2,2,3-trimethylpentane, we have 3 methyl, parent 5 carbon, total 8 carbon. So basically, all these 4 options here consist of the 8 number of carbon. So means that the second things that we are going to look at is the contact surface area or the branches. So we need the highest boiling point. That means we need less branches. So option A is a straight chain alkane. So that's why it is considered has no branch. So the contact surface area is the largest. So the highest boiling point would be N-octane. Now look at one extra exercise. Arrange the following alkane in order of increasing boiling point. Like just now we say, first we check the number of carbon. So 3-ethyl means that ethyl 2 carbon. Di means 2 times methyl 1 plus heptane 7. So total is 2 plus 2, 4, 4 plus 7 is 11 carbon. Octane 8 carbon. 3,3-dimethyl, so 2 times 1 plus 5 equal to 7. 3-methyl hexane, 1 plus 6, 7 carbon. Cyclonone, 9 carbon. 2,2-dimethylhexane, 2,3-dimethylhexane, 2 times 1 plus 6 is 8 carbon. 2,2,3-trimethyl, 3 times 1 plus butane 4, so total is 7 carbon. So basically we know that the lowest compound either is with the lowest number of carbon, either 7 carbon. In this case we notice there are 3 compounds with 7 carbon. So first one here have 2 substitute, and then 1 substitute and 3 substitute. So that means the second number of carbon similar, we look at number of branches. So 2,2-3-trimethylbutane has lower boiling point, followed by 3,3-dimethylpentane, then followed by 3-methylhexane. So next one we look at 8 carbon. So 8 carbon we have 2,3-dimethylhexane and also octane. So again, when we have two compounds with a similar number of carbon, so again we are going to look at the branches. So after 3-methylhexane will follow by 2,3-dimethylhexane and then followed by octane. So next one we will continue with 9 carbon, which is cyclonone. A and E. Okay, so after 9 carbon is done, then we are going to look at the 11 carbon. So 11 carbon basically is only have one. So which is 3 ethyl. So I put the over here 3 ethyl, 4 dimethyl heptane. So I hope you already have the idea that when we want to arrange the boiling point for the alkane, first we look at the number of carbon. If they have similar number of carbon, then we will look at the number of branches. So basically we already finished for the part of boiling point. Now let's discuss about solubility. Alkane and cycloalkane are almost totally insoluble in water because they are. So here they is referred to alkanes are non-polar molecule and therefore unable to form hydrogen bond with water. So basically from this statement we can say that if we want to discuss about the solubility, we have to check the type of intermolecular force. As mentioned here, if water, the intermolecular force for water is hydrogen bond, while intermolecular force for alkane and cycloalkane definitely are van der Waals force because they are different type of intermolecular force, so unable or will be considered of insolubility. Okay, so if different type of intermolecular force insoluble, and if the intermolecular force is same, so they will be soluble in each other. So for example, here they will say that alkane will soluble in non-polar and weakly polar organic solvent. For example, benzene, carbon tetrachloride, and ether, because all these three basically are non-polar molecule. So if they are non-polar molecule, their intermolecular force will be van der Waals force. So same type of intermolecular force, so they will be soluble in each other. So, or another terms, we can use the term, sometimes you may see the terms hydrophobic. Hydro basically refer to water, and then the word phobic basically is from the word phobia. Means that alkane is the species which is afraid with the water. So if afraid with the water, so it will be cannot mix well together with the water, and the conclusion is insoluble in water. Tutorial question number 5. Test tube W and E, A and B is each filled with water, W is with water, V is with ether, and then write down the observation, means what you can see when 2 ml of liquid pentane is added to the both test tube. So before we continue, as like just now we mentioned, this question basically is about the solubility. So if it is about solubility, then we will look at water, the intermolecular force is hydrogen bond, ether is van der Waals force, and pentane also has the van der Waals force. So when pentane plus water, different intermolecular force, so they are insoluble. So if they are insoluble, basically you will say that two layers are seen because they are insoluble. So we say insoluble in polar solvents such as water. So because they're unable to form the hydrogen bond with water. So here you can see that you need to mention that pentane is non-polar molecule, water is polar molecule. So next one, in the test tube B, homogeneous solution is obtained, or you can also use the word one layer is obtained or one layer is seen. This is because pentane soluble in the non-polar solvent. So means that they are able to form the van der Waals force with ether, because both of the pentane and ether are non-polar molecules. After discuss two physical properties of alkane, so now we are looking at the chemical reaction for the alkane. Generally, we can say that alkane is a very unreactive compound. So that's why here we can say that they are inert towards many chemical reagents. Okay, so why this happen? Because alkane is a saturated hydrocarbon and where there is no functional group. So if there is no functional group, that means there will be have less chemical reaction happen. Furthermore, the electronegativity of carbon and hydrogen is almost similar, make the bond between carbon and hydrogen is non-polar bond. Okay, so and then make them very inert towards the chemical reaction. However, they are still undergo a few chemical reaction. First is the combustion, which we know that combustion in bahasa pembakaran and oxygen is needed. Okay, and then the second is the free radical substitution, halogenation, and where maybe this one is the new part for you, which we will carry out continue at the next video. Okay, now let's continue with the combustion of alkanes. In the combustion of alkane, there are three conditions. First, if the alkane burn in excess oxygen, which is complete oxygen, so will produce carbon dioxide, water, and also heat. So normally, if we want to balance the equation, do keep in mind that we need to balance carbon first, followed by hydrogen, and then last is the oxygen. So let's take one example here. Carbon dioxide and water. So C2H6, we have 2 carbon, so we will put 2 over here. 6 hydrogen, so going to put 3 H2O. Then now here we have 3 oxygen and 4 oxygen, so total is 7. So here will be 7 over 2. In another condition is we have limited supply of oxygen. So if limited supply will produce carbon dioxide gas, carbon monoxide and also water. So here carbon monoxide, water, 2 carbon, so here also 2 more of carbon monoxide, 6 hydrogen, 3 more of water. But from here we know that 2 oxygen plus 3 oxygen total 5. So here will be 5 over 2 oxygen. Is at very limited supply of oxygen, the combustion will only produce carbon and water. So we have 3 conditions: excess oxygen, limited oxygen, and also very limited oxygen. Excess oxygen, limited oxygen, very limited oxygen. Then the product is carbon dioxide, carbon monoxide, and carbon respectively. So again, this one we will have carbon plus H2O. So 2 more carbon, 3 more H2O. Total we have 3 oxygen, so 3 over 2. So when you focus at here, 7 over 2 more oxygen, 5 over 2 more, 3 over 2 more. So from here we also can see that the quantity or the amount of oxygen is getting less and less, which can explain the condition of the supply of oxygen. Last question that we will going to discuss in this video, combustion of propane in excess oxygen release gas S. So as we know, if excess oxygen will produce excess combustion in excess oxygen will produce carbon dioxide and also water. And then light water turn cloudy. So again, can double confirm our answer, which the gas S is the carbon dioxide gas, which the correct answer is C. So we already finished the part In this video, basically we discuss about the physical properties of alkane, which is the boiling point. So when we want to discuss about the boiling point, we have to check the number of carbon first. If the number of carbon similar, then only we check the number of branch. Then to remember that cyclic generally will have larger contact surface area. Cyclic consists of larger surface area, contact surface area compared to straight chain. So next, we discuss about the solubility as well. So in the solubility, basically we will check the type of intermolecular force is similar, soluble in each other, or mix well together, which only one layer will be seen. If different type of intermolecular force means that it is insoluble, so two layers will be seen. So then next, we also discuss about one chemical properties, which is the combustion. So we have three conditions of combustion: excess oxygen, limited oxygen, and also very limited oxygen. So basically the product are carbon dioxide, carbon monoxide, and carbon respectively. And then don't forget, all these three generally will produce water. So in next video, we are going to discuss another chemical properties of alkane, which alkane undergo halogenation. So see you in the next video.